Hi everyone, this is the first video for section 6.2 on adding and subtracting fractions. So, like always, make sure you've gone through and read the book, or at least looked at it to kind of see what we're talking about. Like normal, we're not going to talk about every single thing that the book talks about, but just kind of the main things that are the most kind of difficult or confusing concepts from the chapter. Okay, so we're going to talk about adding and subtracting fractions. So we have two different processes to do this. The first process is when things have like denominators, and the second process is when they have unlike denominators. So first off, if the fractions that we're dealing with have like denominators, which is the same thing as saying a common denominator, then all we have to do is add the numerators, right? So if we have a over c plus b over c, then to add that fraction, all we do is just add the numerators. And this is because the c, the denominator, tells us that we have the same size of pieces, right? The c, right? If we think about a fraction as a part over a whole, then that denominator is telling us how many pieces make up our whole. And if we have the same denominator, then the two different quantities we're looking at, that whole is divided into the same number of, into the same pieces, the same number of pieces, and therefore the pieces of the same size. So in order to add that, we just count how many of those pieces we have all together, and that's just the same as adding the numerators. Okay. Similarly, if we have like denominators, again, because the denominators are the same, we again have the same size of pieces that we're dealing with. So the two fractions, our whole is divided into the same number of parts. So therefore those parts are the same size. And we just need to say, if we have, for example, if A was 5 and B was 3. So if we have 5 of those pieces and we take 3 of them away, we have 2 left, because everything's the same size. So you can kind of think of this intuitively like, kind of like units, where we want to add things that look similar, right? So example, if we were dealing with adding 2 hours and 3 hours, well, because they're both in hours, we would just add them up. Whereas if we were dealing with adding, right, 2 hours and 45 minutes, and we wanted to talk about, instead of 2 hours and 45 minutes, we wanted to talk about, instead of having two different kind of units of measuring time there, right, hours and minutes, we just wanted to talk about it in minutes. That's kind of similar to having an unlike denominator, where you need to convert them to where you're talking about the same amount of time, right? 1 minute versus 60 minutes. You're talking about different units of time. Whereas, yeah, you can think about these like denominators as kind of having similar units, because we're talking about the same sizes of things. Okay, so now if we're adding and subtracting fractions with unlike denominators, we have this algorithm that tells us how to do that. So the first thing you do is rewrite the fractions using a common denominator. So sometimes the common denominator that we'll use will be what's called the least common denominator, where the least common denominator is just the least common multiple of the denominators. We can talk about that a little bit more in a little bit more detail later on. So we rewrite the fractions using a common denominator, perform the operation in the numerators, and then write it out and simplify it if we need to. Oh, look at that. So it's not necessary. So this little note here says it's not necessary to use an LCD, least common denominator, which is the least common multiple denominators, as any common denominator will work. So we saw this a little bit in the last section when we were comparing fractions, and we saw that cross multiply was actually looking at a product of the denominators. And in general, if you just multiply the two denominators together, that is, I think, the easiest way to always have a common denominator, is to just multiply the two denominators together. So I didn't spend a lot of time on these algorithms because you should know how to do them, right? We all know. We've all seen fractions before. I guarantee you, if you have not seen fractions before, you need to tell me, because I don't know how you've made it this far without it. But yeah, I didn't spend a lot of time on these algorithms, because you've seen it before. You should know how to add and subtract fractions. We're just making it a little bit more formal. Okay, so we want to evaluate the following fraction problems. Okay, so we're going to go through it. So the first one, A, is adding a sum of mixed numbers. So in case you've forgotten, 2.5, there's an implied addition here. So 2.5 is really representing the value 2 plus a half. And similarly, the value 3.5 is really representing 3 plus a half. Okay, so if we want to add these up, we can reassociate. So we can use the associative law of addition and the commutative law of addition to rewrite this as 3 plus 2, and then adding our fractions. So we can kind of reassociate this as adding our whole number parts and our fraction parts separately. And so when we do that, when we add our whole number parts, we get 5. When we add our fraction parts, we get 1. And this gives us 6 total. Okay. So that's kind of how you add mixed numbers, just because it's not explicitly kind of stated in this algorithm. But if we're adding up mixed numbers, you can just add the whole number parts and then add the fraction parts. And whenever you add the fraction parts, you can use the algorithms that we've talked about above. This one is really simple. 1/2 plus a half is 1, and we should all know that. So we didn't really have to talk about the algorithm as much in this one. Okay, the next one is 5/6 plus a half. So when we're doing 5/6 plus a half, so these do not have the same denominator. So what we need to do is, the first step of adding fractions with unlike denominators is rewriting the fraction with a common denominator. So in this case, our denominators are 6 and 2. So we can rewrite it with the easiest one, like I said, is to just multiply the denominators. So we can rewrite it with a denominator of 12 just by multiplying 6 and 2. But in this case, we know that 2 is a factor of 6 and 6 is a multiple of 2. So that means that the least common multiple of 2 and 6, because 6 is a multiple of 2, is just 6. So we can rewrite this as 5/6 plus 3/6. And then we add the numerators, and the operation occurs in the numerator spot. And this is 8/6, which we can then simplify, because 8 and 6 have a common factor of 2 to 4/3. Okay, so one thing to note here is that typically the problem should tell you what form it wants the solution in. For example, leaving solutions as having solutions written as improper fractions versus mixed numbers. Typically it should be clear from the context which way you should leave it. However, for an example, for an exam or anything like that where you're writing out the answer and not entering it into like WebAssign, you can leave it in any form that is correct if it's not specified. So if it's not specified to write your answer as an improper fraction or mixed number or anything like that, you can just leave it in the form that you get it, right? Oftentimes simplifying an answer further is just one more step in which it's easy to make a mistake. So I don't recommend doing it unless it's a necessary requirement. Okay, so now we're doing 7/6 minus 1/3. So again, 3 is a factor of 6, and 6 is a multiple of 3. So that means that the least common multiple of 3 and 6 will be 6 itself. So we can rewrite this as 7/6 minus 2/6 to be, again, the operation occurs in the numerator part. So 7 minus 2 is 5/6. And that is our answer. So there we have 5/6. And lastly, we are going to subtract these mixed numbers. So again, remember that this 1 3/4 is really written as 1 plus 3/4. So this entire thing, we can write it vertically, I think is going to be easier. So thinking back to whenever we learned how to add, subtract, multiply, and divide whole numbers, and specifically we looked at that in different bases, we can look at this 3 and 1/8 and stack it vertically on top of 1 and 3/4. Okay, so we can look at it this way. So I'm going to go ahead and rewrite this 3/4. So because again, just like part A, whenever adding adding mixed numbers, we could regard it as adding the whole number part and adding the fraction part. Similarly, we can regard it in a similar way here, where we're subtracting first the fraction part and then the whole number part. So I'm going to write this 3/4 as 6/8 with that common denominator. Again, 4 is a factor of 6. So, 4 is a factor of 8, and 8 is a multiple of 4. So that means that the least common multiple of 4 and 8 is just going to be 8 itself. Okay, so we're doing 3 and 1/8 minus now 1 and 6/8. So remember, all of these operations are occurring in the numerator part. So if we're trying to subtract 1/8 minus 6/8, we don't have enough to do that. We cannot subtract 1 minus 6. So what we need to do here is borrow using fractions. And this is, again, really similar. Whenever we borrow with fractions, it's really similar to how we borrowed in base, in using, for example, in this case, base 8. Because if we take one whole away from the 3, we're left with 2 wholes. But remember that one whole is broken up into 8 parts. So whenever we borrow that one whole, we really get 8 parts. Added to this one part is going to give us, sorry, I shouldn't write anything. So whenever we take one whole, break it up into 8 parts, and add it to the one part we already have, this is now going to give us 9/8. Okay, so now we can do 9 minus 6 and get 3/8. And we can do 2 minus 1 and get 1. So this is just going to give us 1 and 3/8. So for this one, we can convert it into improper fractions and then subtract that way. But it's also valid to subtract it in using borrowing with fractions like this, because it mimics what we've done before. In chapter 3, borrowing in base 8 is similar to borrowing when you're dealing with fractions with a denominator of 8, where we have our ones place, and then normally to the left we would have our eights place. But if we instead go to the right, we would have our eighths place, which is 1/8. Okay, so these are just some examples of fractions. If you struggle with adding and subtracting fractions, I recommend just doing a bunch of practice problems. There's a ton of practice problems in the book, and there's answers to the odd questions in the back of the book if you want to do that. But if you're uncomfortable with fractions and doing things like this, I would definitely recommend doing some practice problems. But next video, we're going to talk about properties. So that's all for this video.